First, they just ask us to simplify what is in these boxes here. Okay, so if you notice, the things in the first set of parentheses are all of different degree, meaning higher exponents, lower exponents, or maybe no variable at all, right? Whenever we are adding or subtracting, we can only combine like terms, right? So they have to have the exact same thing in them for us to actually be able to put them together. So in the first set of parentheses, this 2, the first one, has an x squared with it. Is there anything in the other parenthesis that has an x squared?
No.
Yeah, the very first term, right? There's not a number in front of it, so it's understood to just be 1, right? So I've got 2 of these, 1 of these. All together we would have 3x squared. Very good. All right, so I combine my like terms there. I'm done with those. Okay? Now I've got 3x. Anything like it? So I have 3x plus negative 5x. Negative 2x, very good. All right, so I combine those, done with those. Now I've got a 2 and a negative 5. What is 2 plus negative 5? Negative 3, all right? And that's it. That's all they want you to do. Just combine the like terms. Okay? All right, same idea on number 2. This time they're just asking us to subtract the 2. Okay? So I've got a 2x squared, and then I have a similar term over here. Right? So I've got 2x squared minus x squared. What's that going to leave us with? 1x squared. Very good. All right, so we're done with the x squared. Okay, now I'm looking at x, and we've got a negative 4x. So I got x minus negative 4x. Well, minus a negative turns into a, so I really have x plus 4x. Good. Now I'm done with the x's. Last thing to combine is our actual number. So I've got negative 4 minus 1. Negative 5, right? So we just got to be extra careful with our signs. And that's it. That's all they wanted us to do. Put together the like terms. Okay? All right, on this next one, they are asking us to find the perimeter of the triangle. Well, how do you find the perimeter of something? Just add up all the sides. So I'm adding 3x squared minus 4x plus 7, this side right here, plus x squared plus 3x minus 5 plus 2x squared plus 4x plus 1. Right? I'm adding all those up. And again, we can only add like terms, right? So I can add all 3 of these that have x squareds in them together. So I've got a 3x squared, an x squared, and a 2x squared. How many is that all together? 6. Very good. So I got 6x squared. Okay? And then I can do the same thing for the terms that have x's. I've got negative 4x, positive 3x, and positive 4x. How much is that if we put them all together?
3x.
Just 3x, right? Because the positive 4 and negative 4 cancel out, and then we just are left with positive 3x. Very good. And now the constants. I got 7 plus negative 5 plus 1. Very good. Positive 3. All right, so there is the perimeter of this figure. Okay. All right, next question says that if the perimeter of the triangle is 6x squared plus 5x minus 5, and 2 of those sides are x squared plus 1 and 2x minus 1, then what would be the length of the third side? So I have some triangle here. I know that one of the sides is 2x minus 1, This side over here is x squared plus x plus 1. And they told us the perimeter, which is what we found on the last one by adding all the sides up, was this. So what could I do with the total and these two to find what's missing? Just subtract them. But first I have to put these two together, right? So I'm going to add the two sides that we know together, x squared plus x plus 1 and 2x minus 1. Okay, is there any other x squared besides the one in the first term? No. So we just have x squared. Then I got x and 2x. Good. And positive 1 and negative 1. Right, gone. Right? So when we add them up, this is what we get. And then like you guys said, we would just subtract that from the perimeter, which is this number. So we would have 6x squared plus 5x minus 5 minus x squared plus 3x. And we do want to put it in parentheses because we need to remember we're subtracting both pieces, not just the first one, right? Okay, so I've got a 6x squared. Anything like it over there? Just 1, So 6x squared minus 1x squared would, yes, leave us with 5x squared. All right, we're done with those. 5x minus 3x. Good. Okay, done with those. And is there anything to subtract from the negative 5? So it's just going to stay negative 5. So this would be the length of that third side. Okay? All right. Okay, on this next problem, it says to find the area of the shaded region if 9x squared minus 6x plus 3 is the total area of the entire thing, and 3x squared plus 2x is the area of the unshaded region. So this little piece right here, it says, has an area of 3x squared plus 2. The entire rectangle has an area of 9x squared minus 6x plus 3. How do we find just the shaded part? Yeah, just subtract again. So the whole thing, 9x squared minus 6x plus 3, minus the unshaded part, 3x squared plus 2. Okay, so what am I going to subtract from 9x squared?
3x squared.
Which would leave us with?
6.
Very good. Done with those. Is there anything for me to subtract from negative 6x? No like terms. So I just bring down negative 6x. And then we would have 3 minus 2, which would leave us with 1. Alright, so that would be the area of the shaded region. Okay? Alright, last one says to find the total area. It told us the area of all the pieces. They want to know total. What are we going to do? Just add them all up. Okay, so we've got a y squared here, 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 and here. So how many is that all together? 4. So the corners are 4y squared plus the middle, which is 13y squared plus y plus 4. So what are my like terms? The y squared. Very good. So if I add those together, we would get, good. So I have 17y squared. And then there's nothing for me to combine with those other two terms, so we just bring them down exactly as they are. And there's our total area. Okay?